Welcome to the Machine Learning Internship by Internship Studio. In this internship module, we are going to look into a algorithm called clustering. We are going to understand regarding the clustering algorithm, and it is a supervised learning algorithm. Coming to the difference between supervised learning and unsupervised learning. If you see, we have been discussing regarding the supervised learning, right? Regarding classification algorithms and regression algorithms related to the supervised learning part. So in supervised learning, what is the main difference between supervised learning and unsupervised learning is in supervised learning, you have a label associated. So already a ground truth is available with you, and with respect to that, you are formulating your loss function and you are using some iterative algorithm like gradient descent optimization algorithm for minimizing that particular loss function in the training process. So that is how you train the model, right? So there the training is more obvious, and even when you are evaluating your model, that is also obvious to you. Why? Because even in the testing data case, you already have the ground truth with you. So you have your prediction and you have the ground truth, and with respect to that, you can calculate the accuracy or precision, recall, and whatever the other metrics that we have discussed about. So everything is straightforward in the supervised learning. But in unsupervised learning, that is not the case generally. Why? Because you don't have any ground truth or y label that is associated with the data as such. So you have to come up with yourself. You have to come up with some patterns from the data. So you have to identify the relationships and patterns, and you have to do the clustering, or it may be dimensionality reduction. So you have to do it accordingly. So there is no y or ground truth that is available. And in the unsupervised learning, goal is not prediction. So we are not doing any prediction, but you are doing investigation of the x. In the sense, like as I was telling you previously, right, that there is no prediction as such as we do in the supervised learning part, right? But we try to come up with some patterns from the data. And yeah, so supervised learning is the main technique we generally use, right? So whatever the industry use cases and problems that are there, most of them will try to formulate it in supervised learning way. But even unsupervised learning is becoming popular nowadays, particularly the generative models and other types of models that are coming up. So even we can formulate a particular model in unsupervised learning way also. That is also fine, and also it can be used as a pre-processing step before supervised learning, in the sense, like if you take PCA, which is a dimensionality reduction algorithm. uh, Generally, we'll be using PCA to perform feature reduction in the pre-processing step. That is what they were referring to when they refer that. So yeah, so that is regarding the difference between supervised learning and unsupervised learning. Hope you're clear with that. And coming to the clustering part, so what is clustering? Clustering is nothing but we are grouping the data or samples accordingly with respect to the similarities between them. So if you have these many samples here, with respect to the samples here, so these set of samples are grouped in one cluster, and these set of samples are grouped in one more cluster. So whatever similar objects are there, we are trying to group them and make them as clusters. So that is what we are basically doing in clustering. And a clustering is a collection of records, fine, similar to one another and dissimilar to records in other clusters. So if you take this cluster, so whatever the samples or records that are there, they'll be similar to each other. And if you compare the samples of this cluster to other cluster, whatever the sample that is present in other cluster, there will be dissimilarities that exist between them. So that is what they refer to. And yeah, so if you see this kind of data, suppose you have this data, as such, like if you want to find some patterns, or if you want to make some clusters, you'll be doing in this way, right? So in clustering, what happens is you are going to come up with these different clusters from the data. And yeah, so what is the difference between clustering and classification? So in clustering, there is no target variable that is available. But if you see classification, there is a target class that we have to associate your sample, right? So whatever the sample data or a particular single sample that is given to you, you will take it and you will pass it as an input to your model, and finally the output will be a particular class. So you will tell that this sample is associated to class A or class B. You are doing the association there. But here you don't have as such a thing. Yeah, and clustering does not try to classify or predict the values, right? And instead, clustering algorithms seek to segment the entire data set into relatively homogeneous subgroups or clusters. So what we are doing is we are doing some sort of segmentation in such a way that, and it is also a homogeneous sort of like segmentation in the sense like it is uniform, and we are trying to come up with the subgroups or clusters in the data, and the similarity of the records within the cluster is maximized. So you have to group or make the records of one type. So whatever the records are similar, you have to group them in one cluster. And if you see, if you compare a particular record in a particular cluster, and also a record in some other cluster, there should be some difference. So yeah, so you have to justify that, right? In the sense like, if you take, if you're grouping a set of records in one cluster, they have some similarity with them. And if you group, if you take one other cluster, and if you try to see the similarities between them, they should be grouped accordingly with respect to their similarities. So this will become one cluster, and this will other one will become one more other cluster. So even there should be some differences between clusters among themselves as well. Whatever the respective clusters that we were that we were discussing now. So yeah, so it is sort of like, interconnections should exist, and intra dissimilarities also should exist among the clusters. And what is the final goal of clustering? The final goal of clustering is nothing but, we have to identify the groups. So if you have these different records, right? So you have to group them accordingly in such a way that, whatever the records that are closer enough or which are similar, basically, the similarity, the measure of similarity is also the a topic that that we'll be discussing, in the sense like, what is the distance metric that we are doing. Basically, if you try to calculate the distance, so with respect to the distance, if whatever the records that are nearby, you are categorizing them as one cluster, and whatever the ones that are far away, and those particular records are closer to themselves, they'll form one more other cluster. So that is one case, right? With respect to the distance, we are doing this clustering part. So yeah, so we have to explain, or we have to understand more regarding what this similarity mean. So when you are grouping similar records, in which sense they are similar, that is what we have to understand. And yeah, that is where the distance concept come in. So they are telling that group data points that are similar to each other, and identify such groupings in an unsupervised manner. So we have to identify those clusters without any supervision. Supervision in the sense like, there is no prior ground truth or label that is available with us, right? So we have to automatically, or we have to somehow come up with the clusters as is. So there is no prior information that is available with us. No information is provided to the algorithm on which data points belong to which clusters, right? And in other words, clustering algorithm seeks to construct clusters of records such that the between cluster variation is large compared to the within cluster variation. So if you speak of these two terms, between cluster variation and within cluster variation, between cluster variation is nothing but you have two different clusters, and whatever the variation that exists between these two different clusters, right? The records that are present between these two clusters, and the variation between them, that is called BCV, which is between cluster variation. And if you have one cluster, and within the cluster itself, whatever the records you have, if you want to understand the variation between those records, that comes under within cluster variation, which is WCV. So hope you're clear on that front. And yeah, this is what the goal of clustering is. So we have to if you consider these three different clusters, if you see, this is nothing but the between cluster variation. Whatever the pink one that you're seeing, right, arrows, these are the between cluster variation, and black arrows, you can see that it is within cluster variation. So intercluster distance that we are trying to calculate, the sum of distances between objects in the same cluster or minimize it. So we are trying to minimize that. And intra-cluster distance, while the distances between different clusters are maximizing. So this is your intercluster distance which we are trying to maximize, and this black one is the intra-cluster distance which we try to minimize. So that is what we will try to do, and this is what the goal of clustering is basically. And yeah, what clustering does? Clustering splits data in order to find out how observations are similar on a number of different features. So if you have these different features, and we'll try to understand the similarity between the different records or between data samples, then we are doing this clustering part. So now you can see that these particular data points belong to cluster 1. This particular data points belong to cluster 2. So these belong to cluster 4. So yeah, and we are not predicting a true while. And the clusters or the model, we decide the number of clusters represented as k. So how many clusters are needed, or how the model is supposed to assign the clusters, that is one question that we are going to ask, in the sense like we have to give, if you want to give this particular clustering part, or if you are formulating this clustering problem in such a way that you are telling that okay, you have the data with you, and you are also telling that okay, divide this data into 5 clusters, or divide this data into 2 clusters, then accordingly your model is also iteratively will come up with those many clusters. So it will associate whatever the associations that it is doing, it performs it accordingly. So if you give it as 2 clusters, it will try to cluster whatever the records or samples that are present into only 2 clusters. So that is what the significance of k is, or the number of clusters. And to understand it, the clustering part in a more intuitive way, I will try to understand this example. So imagine that you are the owner of an online clothing store. You want to segment your customers by their buying habits. As the owner of the store, you think that some customers are bargain hunters, while others are price insensitive. Some come in every week, while others drop in during the holidays. So there are different customers, right? Different type of customers. Some are bargain hunters, some are price insensitive, and some will come in, visit in holidays, and some will drop in holidays. So there are different categories or different types of customers that are present, or that those customers will visit the shop. And but you don't actually know definitely which one or which. So we don't know exactly like who are who. So we want to somehow cluster them accordingly with respect to these different parameters or features that we are considering. Yeah, so you could take a supervised approach to this problem and try to predict how much a customer will spend, or how frequently a customer will drop in. So obviously, like with respect to the features that we have, we can make a prediction with respect to that, right? But what we are trying to see is we want to understand the data, and we want to from data itself, we want to try to see what data is telling to us without any ground truth as such. So that is where we are trying to use clustering, which is an unsupervised problem. So we are formulating this as an unsupervised learning problem. And yeah, since we have an online website for our store, we have valuable data about how our customers behave online. We select features that will determine how clusters are formed in our algorithm. Since we want to segment customers by their buying habits, we probably want to form clusters using the features, number of visits, and average amount spent. So here we have these different features that are there. So we have a online store, so you can find all this data that is available. So you have customer ID here, you have number of visits, and amount spent, and what is the traffic type, and percentage of visits during sales. So you have all these different features, but we are more interested in number of visits and average amount spent. So if you see, we try to apply clustering on these two, number of visits and average amount spent. And yeah, so these are two features, right? That's the reason when you plot it also, it is plotted on a two-dimensional space, and that is where we are doing our clustering part. So if you see it, you are trying to come up with the clusters part, right? So if you see, these are the number of visits, how many visits particular set of customers are doing, and this is the average amount spent. So ideal cases like, if you see this different set of people, if you see high value buyers here, right? In the sense like, they are visiting frequently and they are also making a higher amount of purchases. In the sense like, if you see people here, this category people are like, they are visiting the store a number of times, so they are doing some 40 to 50 visits, but they are not buying, or the average amount is not high. So if you see, it is somewhere here, right? So it is not higher. But if you see the case here, even the frequency or the number of visits that they are doing, it is high, and also the amount they are spending is also high comparatively. So if you see the green one, they are middle value buyers, so they are also doing good amount of spending, but the number of visits they are doing, it is not that much compared to these high value buyers, right? So that is the reason they are high value buyers. And these people are casual buyers because they are making lot of visits and they are not also spending maximum, right? And these people are low value buyers, so even the visits are less and even the amount they are spending is also less. So this is how, according to this, we are doing the clustering part here. So we have divided our whatever the data into four different clusters. So say we are segregating accordingly, as low value buyers, casual buyers, high value buyers, and middle value buyers, with respect to these two different features, number of visits and average amount spent. And by tagging each of the clusters with appropriate name, context, and business sense, we can focus on each group differently. Um, right. So once we tag or cluster them accordingly, we can make it, or we can make sense with respect to our business perspective, right? So where we have to focus. Suppose if you see the use case here, we should more focus more on high value buyers. Why? Because of them only we are getting maximum revenue or income, so we have to concentrate more on this high value buyers. So if once we cluster, then accordingly we can filter up those set of records, or those particular customers, and focus on them, right? So we can take feedback from them, and we can improve our services, and we can provide them some premium support or something, so that we'll retain those high value customers. So yeah, this is what the business context of the clustering is. And clustering techniques apply when there is no clause to be predicted. As we've seen, clusters can be disjoint. Yeah, so there are different types of clusters, and if you don't have any ground truth as such, we are going for clustering technique. Even for any unsupervised learning technique, we'll be doing the same. And yeah, so a cluster can be disjoint or overlapping. So if you see that, disjoint is nothing but if there are mutually exclusive, in the sense like, there is no overlap that is present across the clusters, or there can be some overlapping that can be present in the clusters. And a deterministic cluster and a probabilistic cluster. So deterministic cluster is a fixed one, so you can directly define it, and it will be as such. So there is no change in the size of the cluster or area of the cluster, or where the cluster is formed and how it is formed. So everything is deterministic. But if you speak in a probabilistic sense, even a cluster can be probabilistic as well. So it can have a stochastic nature, but we don't deal with those kind of clusters basically here. Most of the time we'll be dealing with this deterministic kind of clusters. And you have a flat cluster and a hierarchical cluster also. We'll be seeing that. So we'll be seeing a k-means algorithm, which is a flat cluster, and we'll be seeing hierarchical clustering algorithms also, so that you get a feel of both of them. So yeah, so we'll see it further. And coming to k-means algorithm, so we are going to discuss regarding k-means clustering algorithm, which is a very basic clustering procedure, and it is a commonly used clustering algorithm, famous and popular one. So that is the reason we are discussing this k-means algorithm. So k-means clusters are disjoint, deterministic, and flat. So as we have discussed it, right? Whatever the different qualities clusters are supposed to be, or they can be mapped to. This particular k-means cluster, whatever the clusters that are formed, they are disjoint and they are deterministic and they are flat also. Okay, hope you're clear with this. And issues related to clustering. So how to measure similarity? So as I spoke regarding the similarity, right? So how you tell that some set of samples or records are similar to each other? So obviously distance is one type of metric, right? With respect to that we can categorize that. And again, in distance you have these different types of distances, right? You have this Euclidean distance, you have city block distance, or you have Minkowski distance. So you have these different types of distances that are present. So which one will choose? That is one particular choice that we have to make. And how to recode categorical variables. If you have some categorical variables, how we are going to recode it, and how we are going to represent it, where we can apply this clustering procedure. And how to standardize or normalize numerical variables. So if we speak of the standardization or normalization part, we have these different types of normalizations, right? You have this standard scaling, and you have this min max normalization, you have z-score normalization. So there are different types of normalizations that are present. So normalization in the sense like where we are trying to bring the data in a single scale, right? So a 0 to 1 or some kind of scale. And even we want to even make, suppose you take a min max scale normalization. So you have a maximum value and you have a minimum value, and you are trying to bring all the data that you have into this particular scale. So it is sort of a change of scale that we are doing. And how many clusters we expect to uncover. So that is one more critical question to think. Why? Because basically if we speak of a k-means clustering algorithm, there we have to in prior we have to give how many clusters you have to divide or cluster or segment your data into. So when you are doing this clustering part, you have to tell in prior that okay, this is the data that is present with me, please do divide this data into 5 clusters. If you tell that, k-means clustering algorithm will do that. So it will cluster into 5 different clusters, whatever the data is available with you. So we have to give this k value or the number of clusters in prior. That is one issue. And we have these different types of clustering. You have partial clustering. So partial clustering have this, whatever this k means clustering, or fuzzy c means clustering, or qt clustering. So these different types of clusterings comes into partial clustering, but basically we'll look into this k means clustering comprehensively. And in hierarchical clustering, again we have these two different approaches. We have this agglomerative algorithms, or agglomerative hierarchical clustering, or divisive hierarchical clustering. In the sense like it can be a bottom up hierarchical clustering or a top down hierarchical clustering. We will discuss regarding these things also in the upcoming slides. Yeah, so coming to the k-means clustering algorithm. Yeah, so the input is n objects and a number k. So we have this n objects or samples or records that are present in our data. So we are going to give the data to the model, and also we are going to tell the k value, how many clusters we have to divide our data into, and randomly assign k records to be the initial cluster center locations. So first what we how we will start is, basically this is the flow chart of the algorithm. First we will start with this k records, in the sense like we have this suppose if you have data and you have to divide it into 3 clusters, then what we are going to do is, first we are going to take or assign these 3 different clusters randomly. And once you have done that, assign each object to the group that has the closest centroid. So you are going to calculate the centroid first, and whatever the objects that are closest to the centroid, right, you are going to group that particular attributes or that particular records into that particular cluster. So a cluster have a centroid, and with respect to that centroid, whatever the objects distance between the centroid and the samples or records, right, we will do that, we will take that, and with respect to that we are associating a particular point to a particular cluster. And when all objects have been assigned, recalculate the position of k centroids. So once you have done that, in the sense like you have this all these data associated to the respective clusters, so we have the centroid for each and every cluster. Now you are going to centroid is a middle point of the cluster, right? So we have assigned some particular point as a cluster centroid to the cluster, to every cluster, but that is not the optimal centroid that you can define, right? So you have to again work on that part. That is the reason you are again recalculating the position of centroid. So once you have taken a centroid, again you are calculating the distance between the centroid and all nearby points, and with respect to that, again you are going to shift your centroid or shift the position of your centroid. Yeah, so iteratively you are doing that, and repeat steps 2 to 3 until convergence or termination. So up to the point to converge, you have to repeat this step 2 and step 3, in the sense like you will be assigning the objects to the cluster, and then you are adjusting your centroid, and again next again you will adjust your centroid. So you will be doing these different adjustments to the centroid, and finally it will reach to a particular point where it has an optimal distance between all these different samples across the cluster. Then you can stop your algorithm. So you can tell that your model or your k-means clustering algorithm has converged. So this is how basically k-means clustering algorithm works. Yeah, so if you see this chart as well, you are starting and you are taking the number of clusters k value, and with respect to that you are going to take a centroid and you are calculating the distance between the objects to the centroids, and you are grouping them based on the minimum distance. And if you are not able to do it, you are going to end it. So finally, once the centroids are in the optimal position, you are like the adjustments that we are doing to centroid will not happen. So because it is already like those are optimal centroids, so then you can end our algorithm, k-means clustering algorithm. Up to that point, we have to proceed iteratively this steps. So this is how k-means clustering works. And yeah, so as we were discussing, right, the CM example that we have considered, so the number of visits that a customer is making and the average amount he is spending, and this is a scatter plot. So we have made a scatter plot to understand the data, and we have decided the value of k, total number of clusters in your data. So as I have told earlier that we should know it in prior, right, how many clusters you want to make. So randomly assign each customer to a cluster. So once the sort of like we have we have fixed the number of clusters that you want in your data, you are randomly assigning all these different customers to the respective clusters randomly. And data points are randomly being assigned to pink, yellow, and green grouping. So you have three different clusters here. You have pink one, you have yellow, and you have green. And if you see with respect to the number of clusters or the k value that you are taking here, if you have taken k equal to 2, this will be the scenario, and if you have k equal to 3, this will be one scenario, and k equal to 4, this is the scenario. So in our example, we specified three clusters, but we can tell the model whatever k we want. So we have to give the k as input, and with respect to that, your model will act accordingly. Now, obviously, the question is that what is the optimal k value, or how to choose your k value, right, with respect to the data. That's a general question, obviously, like you are going to answer. To understand that, if you take a very large number of clusters, will cause overfitting. So if you have a high value of k, then it will lead to a overfitting case, right? Why? Because you have this lot of different case, and you are going to associate your samples directly to those different clusters. So yeah, so this is not very useful for making sense of subsets of our data. If k is an example of hyperparameter, the value which is input to the algorithm and is decided by you. So you can think this k as a hyperparameter as well. Why? Because when you are you have to do this tuning part, right? So when you are considering a particular data set, you should be also analyze, or you should work on the k part. So what will be the optimal k value? And then we calculate a centroid for each cluster. So every cluster we are calculating a centroid, and our goal is to minimize the distance from centroid to any observation. So we want to minimize the distance between the centroid and the different records that are particular present in that particular cluster. and the centroids are calculated are the center of their randomly assigned group. So first we are going to take the centroid as the center, and then slowly we are going to adjust our centroid in such a way that whatever the distance between centroid and the sample, right, it is like it is minimized. So that is what our goal, right? Our goal is to minimize the distance from centroid to any observation. So in this particular training process or the iterative mechanism that we spoke of, our centroids are adjusted accordingly. So here centroids are really close to together, and distance to the outer point is very large. We can definitely do better. So we have started here. So this is the initial one. And as we move further, you can see that you can see this, right, how yeah, so how the centroid, if you see, these are the initial ones. We have these centroids close to each other for these three different clusters. But now, finally, you can see that you have these three different centroids centered to these three different clusters, right? So yeah, now we reassign each observation to the cluster group of the nearest centroid. So we are again associating here with respect to the color. We are doing the association part, right? So now we are telling that this particular set of samples belong to this cluster, and this is your center value, or this is a centroid for this particular cluster. And this we are associating, this set of samples we are associating to this cluster, and this set of samples we are associating to this cluster. So we recalculate centroid with the time. Centroids will go further apart. So obviously, like even this centroids also should move, right? So they cannot stay here. So this is not the optimal one. So they have to move accordingly in such a way that finally, like you have some noticeable clusters that are present. So optimal clusters it has to form. We keep repeating the centroid calculation, cluster reassignment until nothing moves anymore. The model is complete. So once you are done with this part, then your model is ready, right? So once the even if you do the iterations part, that is like finding the distance between the centroid and the respective observations or samples, it will be minimum. So even if you recalculate and if you redo it, your the position of your cluster will be same there only. So there is no much change in the centroid position. So that is the reason we are telling that it has converged, and your our model is complete now. So this is how we are going to arrive to a final result in the k-means clustering algorithm.